taught by Mr. Kramer.
No. Every day is born because you're a being of Christ. God tells you that you're Christ.
Try hardest and stuff, so.
What?
I'll try hardest is what I was saying. Everything is important, but that's disgusting. Made by God.
Alright, so I kind of talked to you guys a little bit about strength yesterday. I gave you the 6 strong acids. What are they?
HCl, HCl, HI,
Yep.
H2SO4, HNO3, and HClO4.
Okay. Be able to name those acids.
Fire, what you said, there's only 4.
I know. I didn't put. I put HBRHI are on there. You already wrote them all down, so I'm not going to restate them. Okay? So the strength of an acid is defined by its equilibrium position or its ability to dissociate or ionize. So what I mean is, the stronger the acid, the more it breaks apart. The weaker the acid, the less it breaks apart, and the more it stays in its original form. Okay? Same thing can be said for bases. But a strong acid is an acid that, you want to underline or make a note, that the way to determine if it's a strong acid is its ability to dissociate. And strong acids completely dissociate, which should, this should make sense then for you, that equilibrium lies far to the right. Why?
Strong. It dissociates.
Okay, so if I had one of my strong acids plus water, it's going to completely dissociate to give us that. So I'm virtually going to have no HCl at the end, and we assume that these guys, these strong guys, go to go fully to completion. Okay, when I say fully go all the way to completion, what do I mean by that? Everything gets completely reacted. Okay? Now it says Ka is very large, and this should make sense. If it goes 100% to completion and you were to do products over reactants, you would have it basically be products divided by 0, which is really an undefined number. And so we won't even ever give a Ka value of strong acids. They're undefined. They're so high that they're undefined. Okay, so you will never see a Ka constant for a strong acid, but you will have to know that they're going to be relatively large because of the fact that they completely dissociate and are very far to the right. Now,
So if there's like a true or false question that was like Ka for strong acids,
sure, you won't see one like that, but yeah.
because it says it's large.
Yeah. Yep, you could, yeah. It's unattainable. So large, it's unattainable. Okay? You hear that?
Yeah.
All right.
No moles, like 30.
Age does not tell you how old you are.
That does.
Age does,
Doesn't tell you how worn your body is.
yeah, age does not tell you how you feel. Okay. This is important. It says yields a weak conjugate base. So first off, what's the conjugate base of this strong acid? Okay? So this is our acid. This is our conjugate base. So any strong thing gives off a weak conjugate. Any weak thing gives off a strong conjugate. And it should make sense, right? If this is going to go far right because it completely dissociates and it's really strong, it would make sense that this would be really weak and not react very well with this to go the other direction.
Right.
That makes sense? Okay? So every time we have something that's strong, its conjugate will be weak, and anytime we have something that's weak, its conjugate will be strong. Okay? That is something that you're going to want to remember, because I could ask you a bunch of questions off of that based on, you know, what is the K value for a conjugate? Well, if the acid's strong, your conjugate, if it's weak, it's going to have a low K value. That makes sense? You need to be able to make some connections between that idea. Yes.
If the
weak acids make a strong conjugate base, how would you like collect a conjugate base easily? How do you collect a strong acid? Is what I'm asking.
What do you mean, how do you collect it?
Well, like, how do you synthetically produce it?
So you're saying,
If it lies far right
Sure.
or left, how would you?
Sure. I don't know the answer to that.
Is there a way to artificially?
No,
there
I
are ways
mean-
to shift it right or left, I guess, but.
Yeah, I don't know the answer to that. I mean, yeah, what you're saying is if these guys naturally dissociate and they don't easily get formed, how do you form them?
Right.
Yeah. Okay. What else do I need to say about this? I think that's it. Now, weak acids are ones that only slightly dissociate. Okay? So let's say I've got something like this. This would be my chemical reaction. Okay, this is a weak acid. A weak acid, I guess. And this is going to be a strong conjugate. So, where is this going to lie? Far left, far right, in the middle? Far left. It's going to be far left because what this is saying is this guy's only going to break up a little bit. It's only going to react a little bit. And so if it only is going to break up or react a little bit, you're going to have a lot of this remaining at equilibrium and not a lot of these at equilibrium. And so you would say it would be far left.
Also, to the strong conjugate base.
Yeah, the strong conjugate base is going to keep it from reacting to the right and make it far left. Okay? Always yield to strong conjugate. Okay? Because it is far left, your Ka value will be really small. So what you'll either see is an undefined high Ka value or relatively low Ka values for weak acids.
Like pretty much 0 or 2% low?
What do you mean? I mean, a low number is
Like
pretty much 0.
0.001.
Yeah. Or like 0.00000. Yeah. Yep. And I'll show you a table here in a little bit. Okay. Yields a strong conjugate base. Ka is really small, only just slightly dissociates and lies very far to the left because it does not react very well. Alright, this is a whole bunch of vocabulary words that I just kind of want to get through pretty quickly. I don't want to go so fast you aren't able to understand them, but they're not the meat and potatoes of what we want to talk about. Diprotic, what do you think that just simply means? Okay, so it is an acid that can give off more than, or in this case, 2 protons. Now, I said this earlier, I'm going to hit on this more at a later lesson, but it only gives off 1 proton at a time. Okay, so this would have a Ka1, and then I'd have to give off the other one. And this would be have a different constant. And the reason why I say this is that this guy's strong and completely associates, and this guy's a weak acid. Doesn't completely associate. And this should make a little bit of sense because this should, oh, I didn't put it there. That has a negative charge. Something that's already negative is not going to be as willing to give off a positively charged proton. Does that make sense conceptually?
Yeah.
Everybody? Okay, it's not going to be as likely to give off a positively charged proton if it's negative. Now, if this were positive, it's fairly likely, fairly easily going to get rid of it.
Is an instance where a change in temperature would affect
The change in temperature affects all equilibrium.
I know, but would it dissociate more rapidly the weak one if it's warm, or would that not affect it?
It depends. I don't know if it's exothermic or endothermic off the top of my head.
Right?
Um,
It wouldn't. It only mattered for exothermic or endothermic. It wouldn't matter otherwise.
So oxyacids, they are what they sound like, oxygen bonded with hydrogen that makes up an acid. Okay, an example of this would be something that looks like this. An oxyacid is that sulfuric acid, H2SO4. It's really any acid that has an oxyanion. Do you guys remember what an oxyanion is? Vaguely. A lot of our polyatomic ions are oxyanions. Sulfate, sulfite, nitrate, nitrite, chlorate, chlorite. No. Negatively charged oxygen. Negatively charged oxygen. I don't know. Well, you asking the question.
Or it's like the anion, it's like the second one.
The anion.
What do you mean the second one?
The oxygen's like the second.
Oh, sure. Yeah. I mean,
Which is the anion, so yeah.
yeah. These are always going to be anions. So like, nitrate, nitrite, sulfate, sulfite. Two minus it is, isn't it? I'm drawing a blank. Chlorate, chloride. Okay, hypo. Okay, those are all our oxyanions. Organic acids. This is probably the one I'm going to spend the least amount of time on. Organic is carbon-containing things, or things that have a carbon backbone. There's a whole bunch of organic groups. It just gives one here, a carboxyl group. Typically, anytime you have an organic acid, it is going to be a weak acid. It's not going to easily give off its hydrogen due to the fact that it has a lot of carbons in it. Probably not. I don't know. I have no idea. Yeah, sure. Good. I want to move on to something that's a little bit more important. Oh, monoprotic. What is that just referring to? One hydrogen it gives off. Hydrohalic, what do you think that's referring to?
Halogen.
Okay. Usually they sound like what they are. So like HF is going to be a hydrohalic acid, but you could also call it a monoprotic because it only has the ability to give off one hydrogen. Make sense? Okay. I could, for example, this is an oxyacid, but it also is a monoprotic because it only has the ability to give out one. There's a lot of overlap here. I want to spend most of my time talking about this. He should at least be familiar with the word amphoteric. Maybe you don't remember exactly what it's called or what it means. You guys remember that word?
Yeah, when water is the acid base.
Well, yeah, water is a type of amphoteric. It's not the only one.
Yeah.
Like for
It can be
example,
whatever it needs to be.
yeah, sure, yep. But the reason why when I say amphoteric water product comes to mind relatively quickly is because it's the most important and the most common amphoteric substance because water gets used quite a bit. Okay, there's more than just water can be amphoteric. Anything that has the ability to be either an acid or a base is an amphoteric substance. A lot of common things actually can be that. But for example, I could have H2PO4 minus. That's an amphoteric substance. Could it give off another hydrogen? Yes, but could it accept another hydrogen because of that negative charge? It could. But so it would be dependent upon what it's with. If that were with some strong acid, it's probably going to act as a base. But if that's with a base, it's probably going to act as an acid. Okay? Now, autoionization or self-ionization of water is really, really important. So here's what I want to hit on then. What this simply is when water, when all you have is pure water, it will react with itself. Now when I say react with itself, I'm not saying a lot of it's going to react. You're going to see this by the fact that the numbers that I give you here. But it will react with itself. To form your H3O plus and your OH minus. Okay? So what's interesting about this is one water molecule will act as an acid and another water molecule will act as a base. Okay, so if I had pure water, there is a small portion of the water molecules that will react with themselves to produce your hydronium and your hydroxide ions. Now, experiments show that when we're at room temperature, okay, and I have pure water, my H plus concentration and my OH minus concentration are the same, and is that a really large amount? No, that's not going to be a whole lot of hydronium and hydroxide if we're talking about pure water. So water does not react with itself a lot, but it sets up the stage. What this does is sets up the stage of our pH scale. So quickly I'm going to kind of review and go over what the pH scale is. You guys remember, typically when you think of pH, you think of from 0 to what? 14. Okay, and there's a position that's called neutral. What is that? 7. Okay, well, you get a 7 pH when you have pure water at 25 degrees. Your concentrations are the same. You get a pH of 7. Okay, if I add acid to water, is my pH going to go up or down? Down. So just quickly, you have equal to 7 would be a neutral. Less than 7. Is that how you do less than?
That's greater than 7.
That's so long.
What's
Just
the,
put 7 on the other side.
yeah, it goes less than
It's
7.
less than.
Yeah, less than
There you
7.
go.
That's less than, yeah, okay, yeah, that makes sense. That makes sense. So if it's less than 7, it's acidic. And if it is greater than 7, it's basic. Now, if I were to pull out, grab a beaker of water, get my pH sensor out and check the pH of our tap water, it's not going to be 7.
It has dissolves.
Because it has a lot of ions in it, and we'll talk about how ions are going to actually shift the equilibrium of the self-ionization of water. Okay? In fact, a lot of times what you get when you drink your water is you are drinking slightly acidic water. You're probably thinking, well, don't we die from that? Well, no. You can actually take a lot of a fairly strong amount of acid and still be fine.
Also, like, otherwise no sugar for you,
Sure.
or no flavoring in any food ever.
Yeah. Okay? Now, this you're going to want to make note of. This is a pretty important equation. What this simply says is if I can figure out my H plus concentration and my OH minus concentration, I can figure out the other using this particular equilibrium constant. This equilibrium constant is your self-ionization constant. Okay, so it's with water reacts with itself, you get that same ratio. Could the H plus go up? Okay, well, what would happen to the OH minus? It'll go down. To maintain the same equilibrium constant, remember we can have different positions, but always the same what? Constant, as long as we're at the same temperature. Right?
Indirect relationships. Those are hammered into us last year.
By who?
You. The indirect and direct relationship. Indirect.
I hammered it in physical science, and they still don't know
Last year, or Matthew's?
it. Okay. Oh, I already had this in your notes, didn't I? All right. Now, yeah, so this gives you a pH of 7. This gives you a pH that is less than 7 and greater than 7. So I'm just gonna skip this. All right. I feel like I'm missing something. Some more. Did I skip a question? Do you have a? Huh? That's weird. Well, I have an example in here that you don't. All right, we're going to take a little detour to go back, because I do want to go over, before we go over this, I do want to go over, I want to show you one table out of the book. Turn your books, 644. And you may not think this is important, but this is. So to get there, please. Okay, in here it has a table. Okay, it's got values of Ka for a lot of common monoprotic acids. If you look at their Ka values, what would it tell you probably about the strength of these particular acids? They're weak acids. Now, when I say weak acids, there's levels of weak acids. Does that make sense? Some weak acids are stronger than other weak acids, but they're not anywhere near to a strong acid because we know strong acids have extremely high Ka values, so high you can't even compute them. Okay? So here's what I want you guys to do. So what you have there is you have a table of acids and what their acid strength is. What I want you to try to do is I want you to take the conjugates so these are the conjugate bases of common acids that are in here, and I want you to list them from weakest base to strongest base. Weakest base to strongest base. Not all of these are going to be on here. This is just you can view as a base. This comes from what? And what I told you about strength in relationship to their conjugates should help you answer this using that table. That table tells you the strength of the acid. Well, you know how the conjugates relate to your acid strength if you can figure out where they lie on that table. Now, this one won't be on that table, and this one won't be on that table, but you have the K value of this. I just gave it to you. And this is a what? Or this is a what? Strong acid. Everything else is in that table. So you should be able to, either from the information I've given you about what strong and weak means, also the information I've given you about what the K value suggests, should help you with this. Are you understanding what I'm asking you to do?
Yeah.
The easiest one is probably identifying the weakest base. Yeah? Fine? Water's next. Because it has a Kw of 1 times 10 to the negative 14. That's a weak base. Now remember, this can be treated as an acid or a base, and that's what the constant would be for. And that's by far the weakest of anything on here. Okay, after that, you're probably then just going to compare their acids. So if we're talking about weak base, we want to figure out which of these three is the strongest acid, correct? So what of those three was the strongest acid? What was it? HF. Okay, so F minus is going to be then my next weakest base, or next strongest. Left, right. Okay? What would be next then?
And then that would leave our CN minus.
So what can be said about these? These are my weakest base to my strongest base. This would then be my strongest. This would become from my strongest acid to my weakest acid. Make sense? Okay, it's really important to be able to know what the Ka values tell you, know the relationship between acids and its conjugate, know what the Kw is telling you, okay? Really important to know, identify if it's a strong acid or a weak acid. All those things become pretty important. So to finish, let me look at this here. Okay, it says calculate the H plus or OH minus required for each of the following solutions at 25 degrees Celsius and state whether it's going to be neutral, acidic, or basic. Okay? And remember Kw. You know what you have to do here, or are you confused? Speechless. Okay, I'll just show you guys, okay. As I run into my chair.
It's 1 times 10 to the negative 9.
Now you can do this in your head, you wouldn't need to plug this into your calculator. Because it's 1 times 10 to the negative fifth. So if my OH is 1 times 10 to the negative fifth, wouldn't this have to be 1 times 10 to the negative 9? Yeah. Makes sense? Okay? Now, when you're trying to figure out if it's acidic or basic, when you've just been given OH and H plus, look at which one's bigger. If your H plus is bigger, it's going to be acidic. If your OH minus is bigger, it's going to be basic. Everybody hear me on that? I haven't given you the equation for you guys to be able to calculate what the actual pH is. I'm going to tell you right now that the pH of this guy is 9. Which is basic. So this is going to be a basic. And the reason why I know that is I know the relationship between this and, since it's 1 times 10. I wouldn't be able to do that in my head if it was like 2.3 times 10 to the negative 9.
Log is not based on 10. We've got negative log H plus.
Oh, yeah.
Does that agree, right?
Yeah.
So it's going to be basic because you've got more of the OH than the H. Okay? This one, I know just by looking at the fact that it's 10 to the negative 7, it's neutral. Okay? Because it'd be 1 times 10 to the negative 7, and 1 times 10 to the negative 7 would give you your Kw. Now this one is really, really strong. That is a large concentration of hydrogen ions. Your OH minus concentration is like 1 times 10 to the negative 15.
Yeah.
I think if you actually found the pH of this, it would be -1.
Yeah, it is. It's negative 1.
Which is really not basic, really
It
acidic.
doesn't go that low.
It can go in the negatives.
Yeah.
Yep.
It's supposed to be 0 to 14.
Well, I usually put 0 to 14 because we rarely go into the negatives. But yeah, the pH scale can go in the negatives and can go above 14. I mean, if you're getting in the negatives, you're really acidic, and if you're getting above 14, you're really basic. But it is possible. Now, it's probably not something you would want to deal with in a lab. That's getting a little bit crazy, but
What's science for? That means dangerous things that blow up in your face.
what?
What else is science for?
I mean, I've got like 42 molar sulfuric acid back there.
Yeah. You have pouring gas in all the bottles.
We also have,
That little glass thing over there.
I don't want to say on the camera what else we have back
Dangerous things. The camera should
there. Okay, this one's a little bit more of a trickier problem. Okay? So what it says, at 60 degrees Celsius, the value of Kw is not the same as it was. And we should know it's not the same because what changed? And we know from last chapter that when you change the temperature, the K values will change. The only stress that you can apply to a process at equilibrium that will give you a different K value. Okay? It says using Le Chatelier's principle, predict whether this is exo or endothermic. Okay. So normally it was that an increase in temp made it this. So when you increase the temperature, what happened to the KW? Did it go up? Did it go down? It went up. What does that tell you about which direction it shifted?
Endothermic was shifted right.
Yep. Did everybody catch that? I didn't really get to explain it. Alright, so it was this at 25 degrees Celsius. I increased the temperature and the K value went up, which means it shifted right. Well, we should know that when we do shifting for temperature, we have to know whether heat is a reactant or a product. Okay? If heat is a reactant and you increase the temperature, it would shift right. If heat was a product and you increase the temperature, it would shift left, correct? From last chapter? Okay? So it would have to be endothermic to cause it to shift right to give you more products.
So you knew heat was a reactant?
Yeah, it has to be, because we know that an increase in temperature shifted it right. The only thing that would cause would result in an increase in temperature shifting it right is if it were endothermic. Does that make sense, everybody? If this was like 10 to the negative 15, we would say an increase in temperature caused it to shift left, which in that case he would have had to have been a product. You're increasing a product, it shifts away and produces more reactants. Okay, then it says calculate the concentration in a neutral solution at yeah. You would just take this 1 times 10 to the negative 13 equals really just x squared.
So it's 3.16 times 10 to the negative 7.
Yeah. So then you would just take the square root of this. And why could I say that it was x squared here? It's a neutral solution. So if it's a neutral solution, these two concentrations must be the same. And that's why I can take x times x, give you x squared. Square root of that number should give you like approximately 3 times 10 to the negative 7.
Why no straight? Come on, Maddie.
I know.
I'm still off one day. I'm off a lot. I'm not going to school anymore. I enjoy
Let's apologize. Yeah.
I don't even know if you can use the Chinese. No. Because I was trying to harmonize like I know what it means, but what in the world? Serious.
Take off your phone.
If you actually like, is that right? I have the base of it. Well, like tangents, I would need to know what snow is.
I've got like
Considered like a smooth line, right? It does work if like rough. You know what I mean? Oh.
I'm gonna give you $5 to
Whoa, it's
I'm gonna give you $5 to check that.
Supposed to snap the knots in half.
I know.
It's not snap them in half.
Can.
What?
No, you're not.
Oh,
Thanks, Evan.
Yeah.
Flame comes out.
So not only is flame is not reflecting parallel,
Sorry for your hand.
they are not reflecting parallel to each other. That should tell you what pictures are.
And then this one, what is the conversion for Hannah? Do I have to know that? Kramer, what? I don't know though.
Sorry.
Can I leave it in here?
I'm not doing it.
Okay,
Put it down. Put it down.
This one gives me. Kramer would
Let it
really
go.
does. Is that fine?
Rat trap.
But, so why is
Rat
that?
traps, those are the things to put on.
Rat traps are.
Why does it sound like a
Rat traps are hardcore.
Why? They have
I'll tell you
to
what, they're like.
Rat trap.
Well,
Rat trap.
do you know which equation you're using?
Yes.
Which equation? So C units is a meter per second.
So I just have to get that. Is there a different way to know that besides knowing what the conversion is?
I mean, do you know what equivalent to the conversion?
Kramer! No!
Stretch back.
I don't know what's worse.
I have.
Really? No, I said I don't know what's worse.
What's worse?
Physics or chemistry, I can't decide. I can't decide which one I'm worst at.
My dad applied for a passport.
Alright.
For my sister and I. I don't wanna go. Probably won't get
Open up.
Probably won't get a passport because.
I don't know. I won't know.
What? International terrorist. Yeah.
Mr. Kramer, about what we're doing on Friday is just a chapter test, right?
Yeah. Video anatomy?
Yeah.
Yep. What day is it?
Today's Thursday.
Friday.
Smokes, it's Thursday.
Holy smokes. You stop smoking. Bad for
If I get it right with the random conversion I choose, is that minus less? You know what I mean?
No, you either convert it right, you convert it wrong.
Two cameras.
But what if
Wow.
What are we doing?
Let's see.
That'll be sad.
All I'm doing is looking at the homework.
You guys could just look really excited that you helped.
I love it when he grades our
I wanna
homework.
go home.
Seriously,
I
Marty?
can't wait to fail this test.
I know, I'm so excited to jump down on this test. Oh, he's so tired, he don't think it's like
Which one?
the one from this chapter.
I just like clips of kids working on stuff.
They're not working on anything right now.
Well, they look like they're.
Oh, okay.
That's all I think.
Why do you sit way back here?
I don't know.
Either rear or some flank of the car and put white tires on it.
What chapter is this, 9, 10?
You just cut it out.
Neither.
Oh.
So I would do
You
that
always
around
pick
like
that color. It's good color.
an old Mustang
And this
track.
color is so much, so this color is not out.
That would
Because
be
you put tires on that white on it.
But can we
Yeah,
read blue?
White kind of.
a rare one.
Okay.
Yeah, they'll do now.
Chemistry is blue, it's not.
I still don't. Good grades.
Use light and dark.
Great. I wish I had whatever you had. What do you even do? No, Marty.
I
wish you had it. Well, I wish I had the skill of like fall asleep and still get it out.
Cedarville University. You're welcome.
Supercharged engine.
It comes with its own challenges, I'm sure.
Okay, thank you.
Right, right.
9, 10, 11.
It's either one or the other.
Brevin.
He's at Cedarville University.
why did you put the S in?
Because he didn't put the S in there.
So it's the same exact thing. Only here than-
Alright, Tanner, you said you were gonna take quiz and tests
Yeah,
today?
I totally like blanked out on that. I was like leaving, I got home and I'm like,
Do you have Vista
I
Health
hate
today?
having to
I just have a second.
test.
Great.
It's the worst.
Is after school or?
As is.
I'm here after school. How are you, Morgan?
I'll remind you.
Morgan?
Fire.
You taken, I have some stuff I haven't graded yet. Did you take the quiz the other day? Okay. Test, when do you think you take that one?
To be great, but there are more questions, so I don't think I'm ready for it today, and I don't have, I won't be able to do it.
It would be on good stuff, okay, Kramer, maybe you should, this nano ten.
Sounds like
Crust.
Good try.
What is it?
10 to the negative 9.
What?
So you were only.
Wait, then what
15
is
decimal places.
mega?
6.
Wait, never mind, I think I was on a homework assignment. But I think on my homework assignment I did 9.
It's okay. You're only 15 decimal places off. It's okay, it's not. You're not gonna get doctorate work for
That is
this.
quite the number.
Well, 10 to the 6 versus 10 to the negative 9.
Oh,
Okay,
well.
Kramer, we don't need to rub it in.
I'm sorry, I'm not rubbing it in. I don't need to. I mean, I got students that can't convert to centimeters, so.
Hey,
Big.
Power.
that's rude.
Even though I taught him as a freshman and as in
Who
chemistry.
are you talking about?
I'm not talking about it.
You should use names, I like
It's
it.
Bruce.
Bruce.
It's not.
Is
Who's
Bruce
in
in?
physics?
My physics kids don't even know these things. It's really sad.
That's it.
Is Bruce going to Liberty today?
Yeah.
Bruce, what?
Ah, that's where he
He
was.
paid $600 to fly there. Holy cow.
What? He better be pretty confident he's gonna go there. Alright.
He's just going down
Or
to
at
see
least that's
Nathan.
what Cole said.
Gonna see Nathan and Cameron for his next vlog. Oh, it's her. Ah, it's her.
Alright, first question, and what page?
Page 296, number 20.
296.
Actually, whatever. In the
Who should I pick on here? Trinity, let's start you. We don't ever start in the middle.
Yeah, we always go over
You're right.
to.
I always am like that side or that side, or I rarely start right in the middle.
Okay, well, I guess on this.
You guessed on what the difference is between boiling and evaporation?
So, doesn't evaporation occur on the surface of boiling if like fusible substance?
Uh-huh.
Is that right?
Yeah, or you can really say a little bit more, but. Boiling occurs when the vapor pressure of the liquid equals the atmospheric pressure. Evaporation occurs at all points, at any temperature. Boiling occurs at one temperature. And like you said, evaporation occurs at the surface. Boiling occurs throughout the whole volume of the liquid. What's next?
Number 22.
Okay. Crude oil is purified or refined through a process called fractional distillation. In this process, the different components of oil are separated by distillation. What can you conclude about the physical properties of the different components? Rachel.
Some of them are more viscous.
That's true. It's not a false statement. Not what I would have concluded. But. What was the whole thing with the distillation process and what was required, or how did they separate different liquids?
Different boiling points.
Different boiling points.
And that's because they.
Boiling points aren't a physical property?
Yeah.
It's like
So when you boil, it's a chemical change?
It's like a
No.
number. What?
No, it's a physical property because it's the intermolecular force strength that determines what.
Anything that doesn't change the identity is a property.
But that's not a change though. It's a change.
To the point where it changes.
Okay.
not. Maybe just, yeah. Didn't understand what the physical property was back out there. What's next?
But 31.
31? Did you guys do battleship here? And get 31 right? Tanner,
Huh?
can you do battleship for me? 31? Can you connect the dots? For 31, what are your answers?
A.
Yeah. What?
Liquid for A.
What'd you put for B?
Gas.
Ooh, what'd you put for C?
Solid.
You got that one right?
1 for 3.
What the heck did you do? What page is this on?
Page 297.
Where'd you put it?
Gas.
Yes.
Not solid. 97.
Okay, A is
Oh.
gas. C is liquid.
How do you know?
Tanner?
You just asked me.
No.
Tanner, turn your book.
What?
Really does.
It's page 290, or 291.
296.
It's 291. 1127.
Come on, Tanner, hurry.
No?
Here. I got it. Yeah, okay.
Okay, all right, Tanner. Can you connect the dots between 80 degrees Celsius and 300 torr?
Those aren't all.
80 degrees Celsius.
What phase is
Yes.
that?
It's a gas.
Hey, that's right. You're right. Okay. B, 100 Celsius and 900 torr. What do you get?
Liquid.
Hey, and then you got C right.
Wait, so Kramer, what do you do if it's exactly on one?
You would assume it's going through a phase change.
So you, like, you can't put any of those things, like, yes.
You could say both.
Okay. What is wrong with the sex? That's false. You can't say that back.
You can't say it to her and then not take it back.
No, not all people.
It's like, I don't like people that are like, no, you cannot give me that gift.
Not all
It's
people look
like,
like
you're
princesses.
stealing away my eternal reward. That's just selfish of you.
What? What?
Yeah, when people like won't let other people bless them, they're like, no, I don't want that gift, or I don't
By
want.
calling them a princess?
Well, it's a different type of,
You get a
it's
jewel
an
on your
encouragement,
princess. Thank you, Lauren.
right? You know what I mean? Like,
You get a jewel on your princess.
like if I were to go get a Powerade and give it to someone, they're like, oh, you don't have to do that.
There's a
Please
little
don't
one
do
we say
that.
too.
You're stealing
Did you see that?
my eternal reward.
The
I'm
kid who's
giving
just,
a
like,
gift
staring
of
at
love.
Yes, that little kid. He just stared at you the whole time. He was so
That literally made my life.
You're so cute.
By a cornfield.
He was just like, I asked my mommy to buy me
They
one.
crawl for it. They go through darkness.
The most uncomfortable one was this little kid that we say to, and he just like made eye contact the entire time with me.
You made eye contact the whole time?
The entire time.
The entire time. I would look away because I like start laughing. I know.